Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation. In just a couple of months, believe it or not, it'll be the 50th anniversary of humans setting foot on another world and landing on the moon, of course, with the NASA Apollo missions. So that's, coming up here in the news. We have folks like Elon Musk and NASA and many others who now say, now maybe take humanity to Mars. And so after a little bit of a lull, I would say, just sort of in the news and things with the space shuttle kind of winding down in 2011, human spaceflight is getting a lot more buzz again. And so my next guest on the podcast knows a thing or two about that, about spaceflight, as well as a lot of other different science and engineering topics, as well as what we're all about, which is the intersection of faith and science. And so I'm just really honored and blessed to welcome as my guest on the podcast, Dr. Leslie Whitman. Dr. Whitman, thank you so much for joining the Purpose Nation podcast.
Thanks, Brad, for having me. I appreciate the opportunity.
Oh, no, you're welcome. The opportunities are all ours. Starting right off, what are your thoughts about the 50th anniversary of landing on the moon? Does America need a new kind of moonshot with a space program? Do we go back to the moon? Do we go to Mars? So you say you're the head of NASA. So what would you be doing right now?
Well, I think it's kind of inevitable that humans will want to explore further and further. And so Mars is the next logical step for sure. But, it is quite challenging, and it's hard to believe that it's been almost 50 years since the moon landing. The moon, obviously that was a terrific goal, but it's a heck of a lot easier to get to the moon than it is to take people to Mars and keep them safe and healthy. It's kind of written into our DNA to explore and go where we've never gone before, right, as humans. But one of the biggest challenges of a Mars trip is the fact that it's long. We're talking, even the flyby mission that I was recently approached about participating in would be like a year and a half long flight, and that's not even landing on the surface of Mars. And so, so far we've only had humans in space for just slightly over a year aboard the space station, and that's a very small number of people that have been in space for that long. And, they come back severely deconditioned. We have cardiovascular deconditioning happening. We have bone loss, muscle atrophy. And typically when a person's been in a weightless environment in space for a number of months, they are so deconditioned that they have a hard time even standing up under their own power once they get back.
Right.
And so we talk about, like I say, a flyby mission would be about a year and a half, and we don't even have that experience yet in terms of keeping people healthy for that long, let alone a mission where we'd actually land on the surface and spend a few months on the surface and then come back, which would probably be more like 2.5 to 3 years. There are challenges there in terms of, not just the technology to get us there, but the technology to keep us healthy and safe on the trip. Again, I think inevitably we'll eventually get there, but there are some things that we need to really be taking seriously in terms of our plans for doing so.
Yeah, a few minor details to iron out. So
yeah, exactly.
We'll come back to that in just a minute, but I did want to first give a quick background. Well, I'm going to try to make it quick on Dr. Wickman because there's a lot there, so I don't know how quick I'm going to make it, but here we go. So Dr. Wickman is a professor, research scientist, engineering consultant, author, speaker. She graduated from Willamette University with a bachelor's in political science. Now, I didn't expect that one, but with political science, I guess that's perfect for working in like big companies and government and NASA, right? You got to have that. You got to have universities too.
It wasn't really what I was thinking at the time, but it actually has come to serve me well.
Come in handy, yeah. So, and Dr. Wickman also holds a master's degree in aeronautical and astronautical engineering. That's more along the lines of what I was thinking it would be there.
Right.
And a doctoral degree in human factors and biomechanics, both from Stanford University. And it's more what I expected. Mm-hmm. So, and for more than a decade, Dr. Wickman was an engineer for Lockheed Martin, where she worked on NASA's Hubble Space Telescope and the International Space Station program, and was designated as Lockheed's corporate astronaut, which is a very cool job. I wish I could have gotten that job in a corporate world. Much more interesting. And earned the nickname Rocket Girl. which again, very cool. Not many places you can get a nickname like that. So Dr. Wickman is now the executive director for the American Scientific Affiliation, which is a great group, ASA, kind of a Christian nonprofit promoting dialogue between science and faith. And we'll talk more about that in a little bit. She's also a professor of Aerospace-Industrial-Mechanical engineering at California Baptist University. And before that was, and I guess also still currently is with Azusa Pacific University here in Southern California, great Christian colleges. Continues to work in research as a scientist and on technical and policy aspects of national aerospace and defense issues, speaks around the globe on a lot of these different science and technology issues, as well as, of course, the intersection between science and faith. Also an author of a great book. It's called God of the Big Bang, How Modern Science Affirms the Creator. And we'll have a link to that on the podcast page if you want to check that out. And before I get, run out of breath here, if all of that isn't impressive enough, Dr. Wickman is also a dedicated athlete. And this is great. I didn't, and it's reading the bio there, hadn't seen this before, but also a professional women's tackle football, not like soccer football, but we're talking regular football. Is that right?
Yeah.
That's awesome.
Well, I've retired after my third knee surgery. My doctor insisted on my retiring from football, but it was a blast.
Oh man! But also competitive beach volleyball and indoor volleyball. Now that I can handle a little bit more.
Okay.
It's still playing volleyball?
Yes, absolutely. I play beach volleyball very regularly, and I do indoor tournaments every now and then too. So.
Good. Beach is definitely active. I mean, I can handle, I guess, like when you got the 6 players and the indoor, and like, okay, the ball's coming to me, now I can hit it. But but beach volleyball, it's like my feet get stuck in the sand, and it's like the ball goes right by me.
You get used to it. Yes, doubles on the beach is actually my favorite form of volleyball.
Yeah, it's fun.
Good stuff.
Fun, just intense.
Yeah.
It's a great workout, especially in the sun here on the beach in our sunny Southern California. Okay, so going back a little bit to the space flight theme a little bit. So you worked on the Hubble Space Telescope and International Space Station. We're just talking about, some of the things around astronauts and kind of the rigors that they'd be put through on a trip to Mars. But it sounds like in some of your work there and your history, you did some actual astronaut training as well. So what were some of the things that you did, and what were some of the things that they put you through, and what would you say were some of the more difficult things that you went through?
Yeah, a lot of different things that were. I mean, I thought it was all a lot of fun, really. I got my private pilot's license. I got my scuba certification to be able to participate in water tank simulations or neutral buoyancy simulations in the big water tanks that we use to simulate long duration weightlessness. I went through high altitude physiology training in hypobaric chambers where they do like gradual and rapid decompressions to the atmospheric pressure that you'd experience at 20,000 feet. The reason for that is to have you experience symptoms of hypoxia or low oxygen to the brain, so that if it ever happened when you were in a spacesuit or in a spacecraft that was losing oxygen, you would recognize your symptoms early enough to be able to do something about it before you pass out. Flying aboard the KC-135, which is a NASA research aircraft that is used to fly parabolas and get weightlessness over the top of the parabola for about 20 seconds. It's also affectionately referred to as the vomit comet. So that's where your motion sickness comes in.
First place we've gone there in this podcast, but that's, okay.
Yeah.
Go for it.
Yeah. I did many flights aboard the KC-135. Many of them were zero gravity flights where, like, say, you pull up into the parabola over the top, you get about 20 seconds of weightlessness. But I also, for my doctoral dissertation research on spacesuit design for reduced gravity environments, we did Martian gravity parabolas, so 3/8 of the Earth's gravity level, and lunar gravity parabolas, so 1/6 of Earth's gravity. In each of those, you actually get a little bit longer time. For, again, zero gravity, you get about 20 seconds over the top of the parabola. For lunar gravity at 1/6, you get about 30 seconds. And for Martian G at 3/8 of Earth's gravity, you get about 40 seconds. So during that part of the parabola, you get a relatively short stretch of time where you can do kind of short tasks or elements of tasks that are simulated in a more realistic way in terms of gravity level than they would be in the water tank, because obviously in the water tank you have water drag of moving things around and things like that. So you have some artifacts of the simulation environment that you have to account for. And I went through parachute training, spent hundreds of hours in the water tanks doing neutral buoyancy simulations for the Hubble Space Telescope program as well as the International Space Station program.
Very cool. So we were talking about human space flights and just the dangers and kind of the Mars trip and how intense that would be. And I mean, obviously, a lot of this would be a lot of time, but also a lot of money. I mean, robots are getting pretty good now. So I don't know if you've seen like the YouTube videos of like the Boston Dynamics like Atlas thing that does like flips now.
Oh, I think I have seen some videos of that.
Yeah, so the robots are doing backflips. I mean, so you've kind of done some of this firsthand. I mean, what are the benefits still, to sending humans? Maybe the risks and the costs and everything just outweigh the benefits.
Yeah, I mean, that argument goes all the way back to the very beginning of the spaceflight program.
Yeah.
And I mean, really, it comes down to the one capability that humans have that robots and even artificial intelligence has not been able to replicate, at least not fully, is responding to the unexpected. And the artificial intelligence systems are only able to be as good and responsive as we've been able to program them to be. If there's something completely outside the box that they encounter, then we're still not able to respond as effectively or as innovatively as a human would be able to something completely unexpected. So that's one of the biggest arguments for humans in space. However, you do have the other side of the argument, which is that humans are a lot more costly to keep alive in space than a robot would be on a similar type of mission. You have the risks, of course, of the possibility of danger or even death, and the cost with the life support systems that you have to send along with them and the consumables of water and food. All these things add up to additional launch weight, which adds up to greater cost, both in terms of the original launch from Earth's gravity and the cost of the equipment that you have to pay for, of course. But the other thing about humans that probably is the most important piece is that sending humans on space missions captures the public's imagination and attention in a way that sending a robot doesn't.
Right.
And, that is just a big part of the equation that it's a little bit hard to kind of quantify the value of that. But, it's just a fact. It's like people don't get as excited about sending a robot to Mars as they would about sending a crew of human beings. I mean, It's just so much more engaging from the human element.
Yeah, absolutely. And as long as we have like Elon Musk thinking we're going to need to like flee the planet at some point, he's going to probably keep pushing forward with it. So
that brings up a whole another perspective.
Yeah.
And that the more that I have learned through the research and work that I've done, the more appreciation I have for planet Earth.
Right.
And just the simple fact that, we have so many things going for us here on this planet. And we talk about, finding other planets that are habitable. And, you look at Mars, and the problem with Mars, the biggest problem with Mars is the fact that it's so much smaller than the Earth, that it doesn't have as much gravity, and because it doesn't have as much gravity and it doesn't have a substantial magnetic field, it's not able to retain an atmosphere.
Right.
Let alone a breathable atmosphere.
Can be tough.
And
yeah.
so
no beach volleyball without a heavy suit.
Right.
Although I guess the ball would go pretty far with 3/8 gravity, right?
Yeah, absolutely. I mean, or if you want to play baseball, get some pretty good home runs going. But
the red beaches of Mars, the beautiful red beaches.
Yeah. But see, that brings us to the question of terraforming, right? And the idea of terraforming Mars or another planet is dependent on being able to retain an atmosphere. Here's something that actually relates to both travel to Mars as well as to the whole science and faith thing. The fact that Earth's gravity is exactly what it needs to be to hold on to large amounts of water vapor at 18 grams per mole, yet not strong enough to hold on to large amounts of methane and ammonia at 16 and 17 grams per mole. So think about that. Earth's gravity is balanced on a knife's edge. It's finely tuned to that perfect amount of gravity to be able to hold on to life-giving water, but not to poisonous methane and ammonia in large amounts.
Absolutely.
And so then you go, you look at Mars, which I just mentioned, 3/8 of Earth's gravity is not strong enough to hold on to large amounts of water vapor. So even if you were able to somehow get the components of a life-friendly atmosphere, H2O at 18 grams per mole is going to escape into space more easily than it would on a larger planet with greater gravity. That's a big problem, and I think, some of the ideas for terraforming haven't really been thought through from the standpoint of, well, how realistically or how practically would you implement that? I mean, you'd have to have some sort of a huge structure to contain the atmosphere. Like I can imagine a giant dome or something like that. But again, that would be extremely expensive to build on the planet. So all that to say that, Mars is probably a less hostile environment than Venus would be, the other direction, we're closer to the sun, where it's, the surface temperature is about 900 degrees Fahrenheit, and we have carbon dioxide clouds laced with sulfuric acid. So,
it's the
so
the Cloud City idea is
90 times
for Venus, right? Which is like, basically Star Wars in the Cloud City. I guess you'd have to do that. So that, and you also got 90 times of Earth's atmospheric pressure on Venus too. So it's, I mean, like I say, take your pick, right? Not a lot of great vacation
Venus,
options there. No.
Yeah, Venus would be even more hostile, and you couldn't survive as long as you could on Mars. So all that to say that, where are you going to go? If you're going to go someplace, it's basically the moon, the asteroid belt, or Mars.
Not a lot of great options there. And if you're in the domes in Mars, we're back to indoor volleyball again. So
exactly, but still, you get some killer hops, Imagine how high you'd be able to jump.
Oh man, the spikes would be going way too fast for me. They already are. All right. So, in your background, when did you get interested in science and space and engineering? Did you want to be an astronaut as a kid?
Well, actually, when I was a kid, my first interest in science and actually astronomy in particular started when I was probably 7, 8 years old, somewhere in there. My dad had a telescope, and he'd take us outside and look at the stars and moon and the planets through his telescope. And I just remember being fascinated at that early age, by just, wow, there are other possible worlds out there, and just the idea of, how big the universe might be. And, of course, everybody starts wondering about if there are other civilizations or other intelligent beings out there and that sort of thing. And so from a fairly young age, I was interested in science, and at a fairly young age, I was also interested in being a space explorer.
So what was the political science degree?
You're not going to let that one go.
I'm not going to let it go. No. It was just a kind of good general kind of education kind of thing, or, and then you still had plans, or did you attempt to divert from it?
So there were a few things going on, and it's kind of like hindsight is 20/20, right? So looking back on it, I've been able to kind of put a little bit more clarity around it. But I think at that time, growing up, even, grade school, junior high school, I was always encouraged in my math and science abilities and kind of pushed that direction by my teachers. And when I started my undergrad work, I was thinking about majoring in math, and I was really interested again in astronomy, but there wasn't a whole lot of astronomy available as an undergrad. I think part of it was I thought to myself, well, what am I going to do with this? And I think at that time also, because of where I was with the kind of science and faith connection, I was shying away from a career in science, simply because, I grew up in a Christian household, but went to secular schools. And I remember at a certain point in middle school or junior high, I had a biology teacher who would go so far as to say, you might as well just leave your faith at the door, because what we're going to talk about in this class is almost certainly going to contradict what you've heard at church.
Wow.
And even to my, junior high mind, I was like, that just doesn't make sense to me. I don't understand how, if we really believe that God is the creator that he claims to be, then how can studying his creation contradict who he is? It just didn't make sense. And yet I didn't know what to do with that kind of perceived conflict at that age. And I didn't really know where to turn with it. And I think that in college, I was still kind of, like I say, shying away from that and just wondering how could I be a Christian in the sciences. And so it wasn't until later, it was kind of funny because, I majored in poli-sci. I actually thought about working in international relations. In fact, I even did an internship my senior year at the State Department in D.C. And I realized during that experience that I needed to get an advanced degree to really get anywhere, to be able to do more than just kind of push papers and process visa clearances. I thought, you know what, I'm going to go back and I'm going to do what I really wanted to do in the first place, which was study aerospace engineering and learn more about, the space program and get involved in it. And so in a sense, I look at that as my turning a corner, but it was also in a way, I feel like God was maybe dragging me back into the sciences, even though I was trying to run away from it, almost like a Jonah story. It's like, right. I'm scared to do what I'm designed to do,
Right.
So I came back to it later, but it was, like I say, it was all part of my kind of personal journey, I think.
No, that's great, and thanks for telling. And I didn't mean to press you on it, but it was interesting, and it ended up turning out to be a very good story and background on what kind of brought you into where you are today. Coming back to kind of present day, I want to be sure we talk about it. So tell us about the American Scientific Affiliation. What is it? What are their goals? What do they do?
Yeah, so the ASA, we are an organization of Christians, primarily Christians who are working in the sciences or people that are interested in the science and faith dialogue. We have about 2,000 or so members.
Wow.
Probably closer to 2,500 by the time you add up all the students. We have about 1,000 student members. By the way, student membership in the organization is free. We have an annual meeting every summer. In fact, this year's meeting is coming up in late July, the weekend of the 19th through the 22nd, I believe it is, at Wheaton College near Chicago this year. That's one of our crown jewels of the organization, is the annual meeting that we hold every year, where people come together. We have usually about 5 different keynote speakers on different topics. This year's theme is Exploring Creation, and one of our keynote speakers is Kenneth Miller, who wrote a widely used biology textbook and has also written a more popular book called Finding Darwin's God, which is quite interesting. So he's going to be one of our keynotes. We have other people that will be joining us as well. And in addition to the keynote speakers, we have the opportunity for people to submit abstracts for papers that they want to present and full-blown peer review. And so it's always a really interesting conference that, we talk about all aspects of the science and faith intersection, whether it's questions about origins or ethics or environmental stewardship, appropriate technologies, bioethics, genetic research, all kinds of things. So that's one of our highlights. And another is we publish a quarterly journal. We have contributed papers in that on all kinds of different topics in science and faith, and we often have theme issues that come out that address a particular topic. Those are also available through our website. If you join as a member of the ASA, our annual membership for adult members as opposed to students is $85 a year, so very reasonable. And with that membership, you have access to all the resources on our website as well as the journal issues. We have a growing number of local chapters that are spreading across the U.S. and Canada. I think we're up to 34 chapters across the U.S. and Canada. So that's another thing people can find out about on the website and check out whether there's a local chapter in your own community or if you want to start one.
Right.
That brings the conversation to the local community. One more quick thing, in 2020, summer of 2020, our meeting is going to be at Point Loma, Nazarene University.
Okay.
In San Diego. So,
look forward to it. Yeah, definitely can check that out. Talking a little bit about the teaching, so professor at California Baptist University, and prior to that, Azusa Pacific, Christian colleges, seem like you have great programs, and both of them seem like they're adding even more kind of science and computer science and kind of degrees and things like that. What kinds of trends are you seeing, since you're sort of on the front lines there with Christians attending these classes and maybe majoring in some of these degrees? More entering these fields, less? Kind of how is that changing? Kind of what's the landscape you see on Christian entering these careers?
I think there's definitely increasing interest in having STEM degree programs at Christian universities. one of the pieces of evidence of this that I see is the growing number of Christian colleges and universities that are implementing engineering programs. It's a relatively new thing, but it's spreading across the country. I mean, places like LeTourneau in Texas and Oral Roberts University in Oklahoma have been doing engineering programs for some time. Cal Baptist program in engineering has been around for about, I think it's 12 years now, and is growing. Azusa Pacific has a new engineering program that I was actually involved in starting about 3 or 4 years ago. And so it's something that more Christian colleges and universities are getting interested in, and that is always reflective of the market, right? It's like if they don't think that there are students that are going to take those classes, they're not going to start a new program.
Right.
So it's really exciting actually to see that happening, because I think one of the key factors that would attract a student to take or to go after a STEM degree at a Christian college is the whole worldview thing.
Right.
You know, it's as a Christ follower, how can I use whatever my chosen discipline is to make a difference in the world for good? And I think there are so many opportunities in the sciences, you know, whether you're in engineering and able to, you know, bring new technologies to people that need it, or you're in one of the more basic sciences like biology or physics, and you can help people understand the connections between the amazing world that God's created and how He's put it together with the laws of physics and these incredible synergies between the different parts of creation that have to be just exactly what they are in order for life to exist on Earth. I just think it's an incredible witness to the hand of God in this world that we live in, to be able to learn about those connections and in turn tell others about them, whether that's through teaching or through your discipline within a particular industry or institution. Anyway, I'm really excited that these fields seem to be growing within the Christian college and university network.
Right. Yeah, that is exciting. It's great. It's encouraging to hear that those programs are growing, and hopefully the attendance is going up and getting more Christians wanting to do that. And yeah, I imagine it's kind of a lot of what you said, which is part of it, is it just kind of being in an environment and a worldview where you don't have as much, I guess, of the perceived client conflict that you were talking about earlier. I guess there's probably still some wherever you go, but kind of a little bit more welcoming environment for people of faith.
Yeah, absolutely. We do hear this narrative of conflict so frequently, and we see the publicized debates between Bill Nye, the science guy, and Ken Ham from Answers in Genesis that just, you know, are about these kind of hot-headed debates and that are not very attractive to anyone. And the reality is there are a lot of scientists practicing their disciplines who are faithful Christ followers. And so I think the more of that kind of news that we can get out there, the better, and the more encouraging it is for young people who are considering science as a field to go into, as well as people who might be outside the faith who are interested in science, but perhaps think that, you know, science might be an obstacle to faith. I think it's encouraging for people who might be seeking, who have a great trust in science, to know that science and faith are not at odds with each other, and that there are many people who have found them to be compatible.
Absolutely. Amen to all of that. What I hear from some of our guests, and for folks who typically are attracted to Christian colleges, sometimes they're debating between theology or going into ministry or going into a church or maybe serving in Africa or something like that and going into a science career. Are you seeing that a little bit in some of the Christian colleges, or no? Do students coming in kind of have their minds made up, or do you see that kind of a conflict between thinking, well, I'm really more serving God if I go into ministry versus doing science, you know, kind of not making necessarily that connection?
Yeah, I mean, no, I think that, you know, that conversation is definitely one that comes up a lot on a Christian college campus, you know. But I think that if we have thoughtful conversations in class where, you know, we talk about how, you know, you can serve God in whatever discipline that you're in, and to be able to figure out how within your discipline you can practice your discipline really as an act of worship. How can you do it as unto the Lord? And I know in the sciences, just exploring these amazing connections, you know, and the intricacies of God's work, and, you know, God as creator of everything and establishing His covenants with the earth and the laws of nature, and why do we even have an orderly universe? Why do we have these physical laws that govern space, matter, time, and energy, And those kinds of questions and seeing those connections, if we can talk about them so seamlessly in our work, and I know for me, worked in the aerospace industry for many years, and the more that I've learned about the connections between science and faith and seeing God's hand in nature, the more it has freed me up to have interesting conversations with people who may or may not be people of faith about these connections, and just being able to have those did you know kinds of conversations about did you know how improbable it is that we would get the universe that we live in, or did you know these things about the gravity of the Earth being just exactly right to hold on to water vapor but not to methane and ammonia in large amounts, and having those did you know conversations with people and getting them to think more about the possibility that maybe this universe is put together for a purpose. I think it's a ministry in itself to be able to have those kinds of conversations, whatever your discipline is, whether it's in the STEM field or in something entirely different. I think figuring out how you can use your specific discipline to serve God within it. I mean, God needs people everywhere, not just in the church or in the pulpit or in the, professional ministry category. It would be a pretty dark workplace if there were not Christians in every discipline.
I guess the message is you don't have to choose between ministry and a career in science, for example. You can do the both. Why not?
Exactly.
Yeah. So again, we've been speaking with scientist, engineer, author, professor, athlete, as I understand it, Dr. Leslie Whitman, and great conversation. We have lots of information on our podcast page. We'll put a link to the ASA, American Scientific Affiliation website, in case you missed that earlier. Go check them out as well. Try to attend one of their events, sign up for their quarterly newsletters, become a member. Also check out her book, and she has a website as well, so please check all of those out as well. So any big plans this summer? So we have the ASA meeting, but any other projects or trips or things coming up this summer?
Yeah, I mean, the main thing really is our Wheaton conference. So that, we're madly running down all the last minute details for the meeting and making sure that our members are going to have a good experience there. So I'll be going up to the Northwest at some point too, because that's where my roots are. And I tend to hang out around the coast of Washington and Central Oregon, where my family lives, just for fun. But like I said, our big event really is the Wheaton conference this summer. So I hope some of your audience will think about attending. Again, the website is asa3.org, and maybe I'll see you in Chicago.
Yeah, absolutely. Pick up a beach volleyball game over there at the conference.
Yeah,
kind of court.
Sounds good.
well, very good. Thank you so much, Dr. Wickman, for your time, and wish you the best in all of your work that you're doing, and thank you for everything that you are doing.
Thank you, Brad. This has been a great conversation. I've enjoyed it.
Likewise. God bless, and thanks for joining us.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation.